In addition to the complex reverse foiling factoring that we've been talking about, there's a few other types of factoring that we need to go over, so that's what this video covers. Let's move on. Factoring what's called a difference of squares. The word difference means subtraction, so you see all of these have subtraction in them. And then of squares, that means perfect squares. So for example, 49 is 7 times 7, and x squared is x times x. So this is a difference of two perfect squares. This also is a perfect square. It is 2y times 2y, and 81 is 9 times 9. So this is also a difference of squares. Now the way these factor is they always factor the same way. They factor into what's called a sum and difference pattern. So we're going to have one of the binomials will be a plus and the other will be the minus. And all you do is you put that square root in there. So the square root of x squared is x. The square root of 49 is 7. 7 times 7 makes 49. And you see, if you do your outside and your inside in the FOIL process, they actually add up to 0. There is no middle term. So your answer would be the quantity x plus 7 times the quantity x minus 7. On this one here, we recognize that it's a difference of squares, so that means we can do this quick factoring. These are some of the easiest things to factor is when you have a difference of squares, because you know it's going to be a sum and difference pattern. So we put our 2y here and here, and then we put a 9 here and a 9 here, and one of them is going to have a plus and one is going to have a minus. And that will be the same thing as that. So that's how that factors. Now in this problem, this is a difference of two perfect squares. Also, we have y times y, make sure y squared. We're going to have 1 plus and 1 minus. Now the big question is how do you make 1 over 25? Well, that would simply be 1 over 5 times itself. So that's what that answer would be. Now this last one's a little tricky because if you look at it, it's a difference, but it's not a difference of two perfect squares. 12 is not a perfect square. So what you want to do is first look and see if by chance you could factor something out. And we get 4 minus a squared left inside a parenthesis when we factor out a 3. And then the stuff that's left behind there, we could actually factor that into two separate parentheses. That would be 2 plus a and 2 minus a. So that's how that would factor then in the end. So the final answer would be 3 times the quantity, 2 plus a and 2 minus a. So 3 different factors total. Plus now here's two different formulas that's called the sum or difference of perfect cubes. So sum or difference of cubes. These are a couple of somewhat bizarre formulas that you need to just have access to or try to memorize. This particular slide shows you some of the things you could think about when you're trying to memorize it. But what you do is, we're not talking about a difference of two squares, we're talking about a difference of two perfect cubes. For example, 27 is a perfect cube because it's 3 times 3 times 3. We're going to look at a couple examples on the next slide, but here's the two formulas that we're going to be using. Now here's the two examples that we're going to do. The first one is a sum of two perfect cubes. You see the first part, x, would simply be x to the third power. Then we have a plus sign, and then 125 is also a perfect cube. It is 5 times 5 times 5. So in the formula on the previous slide, our a is going to be x, and our b is going to be 5. So that formula, remember, was, well, the first parenthesis was a plus b. So we're going to write x plus 5 in there. Now the formula, again on the previous slide, had a squared minus a times b plus b squared. And that would be the second half. So a squared in our example here would be x times x, which is x squared. And then we have a times b. So that would be 5x. And the formula has a minus sign in it, so we put the minus sign there. Plus our b squared, so that would be plus 25. Now, I can't help myself, but I always look at that part, that x squared minus 5x plus 25, and just ask myself if I can factor that further, and the answer is no, you cannot factor that further. So our final answer to x to the third plus 125 would be the quantity x plus 5 times the second quantity x squared minus 5x plus 25. All right, so the second example, let me zoom in a little bit here on this. This time we have a difference of two perfect cubes. So our A is going to be 3x, because 3x times 3x times 3x makes your 27x to the third, and your B is 1, and we have a minus sign. So the formula that we're going to use is given a to the third minus b to the third. Our answer would be the quantity a minus b times the quantity a squared plus ab plus b squared. So that, again, that comes from the previous slide. So I figured out my a and I figured out my b, so I'm just going to plug those in. 3x minus 1 and 9x squared. Where on earth did the 9 come from? It was our 3x times 3x. Plus 3x times 1 is 3x, plus our b squared is a 1. So that would be our factored form for 227x to the third minus 1. So these two formulas, the sum and difference of cubes, are something that you're going to need to have in your notes and have access to so that you can factor these sum and difference of cubes successfully. All right, good luck.